Hi and what's up everyone. In our today's video I want to show you something interesting, how to create a IoT project using Microsoft Azure IoT Central Application, and this is gonna be an interesting project guys. Alright, this is real-time data I'm receiving in terms of temperature and humidity, and this is actually just refreshing after every 10 seconds. As you can see, I have just received this data in this minute, and this is a heat map of the same data being received. And in this video, of course, I want to show you how to create something like this for your own consumption, and of course you can even monitor your temperature and humidity of your room, all right. Now to get started, I have summarized the steps in this project. It's gonna be very short and gonna be interesting. The first thing, you need to understand the required components and of course the right wiring diagram. Okay, the wiring diagram is very easy because you just need two components. The first component is ESP8266 with its sensor, which is DHT. You can choose any of the DHTs. You can choose DHT11 or DHT22. And the wiring diagram is straightforward. DHT22 or DHT11 usually have 3 pins. The first pin usually in ground, and in between we have the signal pin, and on the other end usually have the VCC pin. Alright, the VCC, of course, you have to connect it to the VCC of ESP, and of course the ground to the ground of ESP. For the signal pin is where I want to mention something. In the code definition, you notice that I have defined in my code DHT pin number 2. DHT pin number 2 for this case represent GPIO number 2. So I have connected it to D4. If you use GPIO 4, then that means in your code you have to define this as 4, because that is GPIO number 4, which now means that for your DHT you will have to connect it to pin number 2 of your ESP8266. I hope it's not confusing, but if you find it confusing, please just connect to pin number 2, and let's have your DHT connected to pin number 4, which is D4 of your ESP8266. But essentially in the code we are following the GPIO definition. All right. Now the next step in our summary steps is to create an Azure account. Let me mention that I have summarized these steps again on my GitHub, and this is the repository, which is very easy to follow, but everything is not in the repository, so it's key to follow this video. Now you need to create a Microsoft Azure account, and for you to create a Microsoft Azure account, if you do not have one, you notice that Microsoft is always giving up to $200 credit for you to utilize the resources. You can just navigate in that link, which is provided in GitHub repository, and of course in the video description, and create your own Microsoft account. The next thing you want to do is, of course, create what is called IoT Central Application. There are various methods of creating Microsoft Azure IoT Central Application. One of them being navigate into Microsoft Marketplace, where I am at the moment, and then click create a resource, and search for IoT Central Application. When you search for Microsoft IoT, or when you search for IoT Central Application, it will show it's the first one here. You can use that method to create one. You can just click create. You have to choose the subscription, you have to choose the resource group. If you do not have a resource group, you can create one by just providing a name, and you're good to go. Let's say I want to create it in my resource group, which is IoT Central, and then you have to give it a name, say IoT Central. I can call it IoT. Let's I represent IoT, then C Central, IoT Central DHT22. Or you can just call it that. URL name, yeah, it's just perfect, it marked. And then template type, you can use custom. Look for custom application. And then for regional, depending on where you are located, you can always choose the regional. The proximity here is the factor. So if you are in US, if you are in UK, depends on where you are. So you can choose any of the locations. For the pricing plan, you can choose standard 0. After you're done, you can review and create. The second method is my favorite, and let me show you how to go about it. Navigating to apps.Azure IoT Central homepage. This link, I shall also provide it in the video description, and it looks like this. This is pretty also straightforward. You just click on build and you can create an application. If you look at this point on the left side, you can see your apps. Now when you are on build, creating an application is simple. Just create application, and then you can call it a name, say DHT IoT Central DHT22. Then you are going to go, and here what we do is we use standard 0 for device sending messages per day, 2 free devices, 400 messages per month. So it's just for learning purposes, so that means we can just use it. Billing, let me use my account, and subscription just for student. This is a basic account which I've been using for teaching purposes. And then the next thing you do is of course create. It's as simple as that, guys, and I hope it's straightforward. Now after creating your Microsoft Azure IoT Central application, let me return back to my GitHub repository. The next thing, of course, you have to understand the wiring diagram. I have explained that, and of course the DHT, and of course everything, the configuration of the circuitry. Now I want us go to of course customizing our application. Let's give it some time. It's done in creating, and I want us customize our application. This is another place that we have to really pay an attention. When it comes to Microsoft IoT Central application, it's something very different to compared to IoT Hub, where we have been doing almost everything by our own. So you notice that in Microsoft IoT Central application, we have some default templates. That means that if you want to really connect a device that already exists in IoT Central application, you do not need to struggle. If you click create a device template, you notice that we have many existing device templates. Now if you wanted to connect a device that already exists in this platform, then that means you would not really struggle. You just choose it and customize it. Alright, now since a ESP8266 does not exist in this template, what we want to do is of course create a new custom IoT device. Now click on IoT device, which is custom. We want to customize our own, customize it, and then give it a name. Let's say DHT22 DHT, let me call it ESP in DHT. Let me just call it that, ESP DHT. That's a device name, and then review and create. After that, I want us to create a model for it. We don't want to import any. Click create model, and then what you want to do is add something called capabilities. First call it temperature. For the name is temperature, it automatically updates itself. The capability is temperature, and of course the semantic type, let it remain temperature. And then we add a second capability, call it humidity. For the name, it automatically updates itself. For the capability type, it automatically of course updates itself. And also for semantic type, let me call it humidity. You can choose relative humidity. Save this, and after saving it, you notice that now we have added the capabilities. This device can receive temperature and humidity. What we do next is customize the graph where we want this data to be populated. Now click on review, and what we want to do is we want to generate default views, and these default views will be generated automatically from the capabilities that we have already created. Now just click that, and then you want to generate default dashboard views. Alright, now if you click on overview, you notice that your already default your overview has been created. It's more of a dashboard on temperature and humidity. what I want us to do in this is just do a quick customization by clicking on this, and of course you can change the color, you can customize it to whatever you want. But most importantly is I want us to have this as the last known value. Just click this icon here and put it as last known value, and of course for this one I want also it to display for the last 30 minutes, and then the interval is 1 minute. You can customize the color. Let's say for the temperature you can pick red to be your color. For humidity you can pick any color. You can pick, let's say, this color, and then update it. And after you sure that that is what you wanted to customize for your dashboard, then you have to save. After saving, what you do next is publishing this. Now you get back here and then click publish at this point. Now you want to publish this, and after publishing it, you notice that if you click on the devices, that device will appear. Now this is not a device, this is just a template. Now what we do next is we create a device. Click on the new device, and what you do, you give it a name. Let's say ESP8266, and there's a portion here which end past where you have to assign a template. Now as you can see, we have our template which was ESP8266. You select it and then you have to click create. Everything else leave default. Alright, now if you click this device, I think you realize is it has been associated to our templates. Now this device is waiting for data and it keeps refreshing itself. Now one of the most interesting parts that I want to tell you to copy is on this aspect of connect. If you click on connect, it will give you the connection strings. You will require this ID scope, so you need to copy that to your text file. Name it ID scope. Another most important thing is the device ID, so you need to copy it as well and paste it on your so this device ID. And then another interesting thing that we need to copy is the primary connection string. This is more of the SAS, or the shared access signature policy, that allows you to connect to this device, and you're good to go. After copying so this is the SAS. After copying the three, the next thing in these steps, of course, is on coding. Now on coding, I have provided the link to access the code. Navigate to my GitHub repository on this project, and of course I have provided the link to download the code. You can use this link, which is just embedded link, or just you can download it directly from the files in the repository by clicking at this point. You just need to download it and extract the files, and after extracting the files, you find that you will have these files. These files, we have the SRC. These are mainly extensions which convert this code, which convert the raw telemetry to something, to JSON data, which is being sent in IoT Central Application. But most importantly, you have to open this file. And after opening this file, I have explained severally that if you're using DHT22, like for my case, you have to change this part as DHT22. If you're using pin 2, which is now GPIO pin, again you have to change this. If you're using pin DHT pin number 4.2, you have to change it depending on which GPIO you are using. I'm using pin number 2 here, which corresponds to D4 on my board. So I have connected my signal pin to number 4. That is why I'm using pin number 2. Now, two things will change: the DHT pin that you're using, and of course the DHT type. The second thing you do is have your Wi-Fi SSID and of course the password. So this is my Wi-Fi name, this is the password to the wireless area network that I'm using. And I want to mention, there are some students who asked me, and don't have Wi-Fi, and what do? You can create a hotspot using your mobile phone, and of course have an SSID and your password. Now we have copied three things. We have copied the handy aspect, so you have to paste them here. We have the device ID, which is here, then you copy, paste it here, Then we have our SAS key, which is this one here. Need to copy and paste it as well, and then save. Another thing you'll note is, which is key in this code, is the interval for sending the data, which is coded here. Now I want to send this data after every 10 seconds. Now this is in milliseconds. Now if you divide by 1,000, you notice it's like 10 seconds. You can change this depending on the time you want to send your data on Microsoft Azure IoT Central Application. Okay, and you're going to go save your code and upload. Well, if you're using this IDE, you have to select the board. I'm using ESP8266. Of course, it's the one that we are using in this project. As you can see, it's ESP8266 module. And then, of course, you connect it in your laptop or in your PC for you to be able to program it. Now, I want to connect mine. The second diagram is pretty straightforward. You just need your two hardware, that is your DHT and of course your ESP8266 board. And what you do is, of course, connect your ground pin to the ground of ESP, connect your VCC to the VCC of your ESP8266, and of course your signal pin to D4, which is GPIO number 2. Remember, D4, as you can see in the video, is my GPIO number 2. Alright, now after this is done, of course take your USB, which is plugged into your computer, and of course plug it into your device. I have connected my hardware and it's in converting. Now I want to upload the code. To uploads, I want to mention something I have explained in my repository on troubleshooting aspect. Now these are just asks for this project in case you find any errors. If the Arduino code is not compiling, there are some few aspects you need to look at. Now I have checked it keenly and I realized the recent or the current library for ESP8266 doesn't work. Now you have to install the old version of this library, which is from 2.5.4 or 2.5.43 library, and your code should run perfectly. Alright, the second error that you might get is now you see it's mine has already compiled, it has already uploaded. Now that error is passed, and let's see if we get some data here. Let me open the terminal window, operation ID. Okay, let's see what happens. Now it is trying to connect to my cloud device. It's already connected. Let's see if it will send some data. It has already. So now this is another error actually that I wanted to show you. It's seeing none. Now I've really explained this error here as well. If it is showing null data on serial monitor, this kind of an error, you have to first thing confirm your wiring diagram. Now let me confirm my wiring diagram to just make sure that my signal pin is in D4, since I have defined it as GPIO number 2. And then of course making sure that my VCC and ground is well connected. That is how you troubleshoot that. And let me check that. Alright, then restart my device again. This is the third error which might happen if you find that your device is not connecting to IoT Central Application. You might find that it's an issue with your connections. Let me try this again and see what happens. I want to clear this and of course reconnect once again. See if I will receive some data on. Oh yeah, interesting. Now if I refresh here, it's actually refreshing itself. The one thing you notice is after it's already disconnected, what might have happened? Let me see. After it reports, what happened is it changes to the state to provisioned. Now let me see. It's this. Oh yeah, it can send some data before disconnecting. All right, let me refresh this. It is sending real time data, as you can see, and I don't know why it shows disconnected. Maybe that is the previous state after I restarted it. But let me just be sure that everything is working fine. Wanna restart it again, and of course refresh this one here. All right. Oh yeah, it's now connected again. Now I hope you have enjoyed this video, and please remember to leave thumbs up, like, subscribe, and share with your friends. Thank you so very much. If you give the dashboard some time, this is how it appears. Of course, you'll notice that you'll have some data populated. This is the temperature and humidity.